Welcome to the 2018 walkthrough for Pure 3, Unit 3 Pure. We're going to start off with some modulus questions, and we're going to go ahead and jump on to, before we start solving, you need to kind of grasp an idea of what's going on with these graphs. You haven't got to draw the graphs to do this, you can just stick to the method of considering like pluses and minuses for these guys. But I'm just going to jump over to Desmos just to give you a bit of idea what's going on. So we've got a mod graph of 2x, what was it? I think it was plus 1. Yeah. Oops, let's get that inside the bracket. Plus 1, close the mod. There you go. Okay, so that's pretty cool. And then what we're going to do is we're going to add another graph of 3 mod x. And the other graph is minus 2. There you go, okay. Oh no, obviously that's got to be in the bracket, so it moves it right. Sorry. There you go. So we've got two points of intersection between the green, the blue and the red graph. There's one there, and there's one down here. Okay, and you can see the answers are 7 and 1. Let's try and get those through algebra on our exam page. So how would you have known that, what that would have looked like? Well, you do need to get used to drawing graphs like 2x plus 1. Why does 2x plus 1 look like it does? Well, it's the 2x graph move, well, I say 2x is the y equals 2x graph. The plus 1 is inside the modulus function, which means it moves left. It can be a bit of a catfish with people thinking that it needs to move up 1, but it's not. It moves left 1, so it goes there. Okay. Or even though, by the way, even though I say it means left 1, you can see that it actually touches at minus 0.5. And the reason for that is because you are multiplying by 2 the x, which means you half the x value. Okay. And likewise here with this minus 2, this blue graph moves to the right 2, rather than where you may think that minus 2 drops it down to. So we've got maybe like a lower gradient that hits at a half, and then a taller gradient that hits at minus 2. So it's going to go ahead and go like this and bounce up. So there are 2 points of intersection, one close to 0 and one further away. And that's what we're going to be looking for, that guy and that guy. So let's go ahead. So remember that when you're solving with mods, there's a plus and a minus version of each. And we've got plus 2x plus 1 and minus, sorry, equals plus or minus, I'll put the 3 outside, x minus 2, like that. And we don't need to do all 4 of these, and by 4 I mean the plus and the minus and the plus and the minus. We just need to do a plus version, which will be the 2x plus 1 equals 3 times x minus 2, and then a plus and a negative 1. So plus 2x plus 1 equals minus 3x minus 2. The reason why we only need to do those 2 is because if I did a minus version by putting a minus here and a minus here, it would give the same answer as the 2 pluses. So there's no need to do that. And likewise, if I swap the signs here, it would give the same answer. So again, no need. Expand on this top one. We get this. We can take all the x's to the right to get 1x over here. And we'll take the 6 over to get 7. And we add 6 to both sides. So x equals 7. And that's very likely going to be, well, I say very likely it is. It's that one. Okay, so that's 7. And the other value is 2x plus 1 equals minus 3x plus 6. Take the 3x over by adding 3x. That's 5x. Take the 1 over. That's going to be 5. And x is going to be 1. And that's going to be that guy. So that worked out really well. So it's best to have like an idea of what's going on in a graph like this, because you may accidentally pick up some solutions that don't exist due to the nature of the mod graphs, where they continue their paths down here before they've been modded, and solutions could exist there that don't exist in when after they've been modded. And that's that question.